What if I told you that somewhere out there exists a version of a human being so rare, so statistically impossible, that finding them would be harder than finding a specific grain of sand on every beach on Earth combined? Not a superhero, not science fiction, a real biological human built from real traits that already exist in the human gene pool. The question is, what would it take to combine all of them into one single person? And does anyone, anywhere, even come close? Today, we're going to build that person, piece by piece, using the rarest documented human traits in history. By the end of this video, you'll understand just how fragile and absurd the concept of normal really is. Stick around, because the final number we land on will genuinely shock you. And if you're into deep dives like this, hit subscribe now. This channel exists for exactly these kinds of questions. Let's start with something simple: blood type. Most people know the basics: A, B, A, B, O. But there's a blood type called Rh null, nicknamed golden blood. Fewer than 50 people on the planet are known to have it. It lacks all Rh antigens, making it compatible with almost anyone in an emergency, but nearly impossible to receive blood from. People with this blood type often can't get transfusions if they need them, because there's almost no donor supply anywhere. Now layer onto that something most people have never heard of: tetrachromacy. Most humans see the world through three types of color receptors. Tetrachromats have a fourth, allowing them to perceive up to 100 million colors, compared to roughly 1 million for everyone else. It's almost always linked to a genetic mutation on the X chromosome, and it's only been confirmed in a tiny number of women worldwide. So far, we already have someone with 1 in a million blood and possibly 1 in tens of thousands vision, and we're just getting started building this person. Here's where things get complicated. Some of the rarest traits in the world don't just stack neatly. They actively work against each other, biologically speaking. Take the CCR5 delta 32 mutation. People with 2 copies of this gene are naturally resistant to HIV infection because the virus can't enter their cells properly. It's found in less than 1% of the global population, concentrated mostly in Northern Europe. Sounds incredible, right? But here's the conflict. Some studies suggest this same mutation may slightly increase vulnerability to certain other infections, like West Nile virus. Nature rarely gives you an advantage for free. Then there's the trait of natural, fast-twitch muscle dominance, combined with an unusually low resting heart rate, something seen in elite endurance athletes. Some rare individuals have hearts that beat as slowly as 30 beats per minute at rest, yet can spike to elite performance levels in seconds. The problem? This combination is genetically tied to specific mitochondrial efficiency markers that are almost never found alongside something like superior color vision or rare blood types, because they come from completely different evolutionary pressures. One favors endurance in cold climates. The other favors visual acuity in different ancestral environments. In other words, the rarer the traits get, the more they start to genetically contradict each other. Building this rarest human isn't just rare, it might be biologically paradoxical. So how do scientists even calculate something like this? This is where population genetics comes in. Researchers estimate trait rarity using allele frequency. Basically, how often a specific gene variant shows up in a population, multiplied across every trait you're stacking. If Rh null blood occurs in roughly 1 in 6 million people, and a specific tetrachromacy variant occurs in roughly 1 in 10,000, and the CCR5 double mutation occurs in about 1 in 100, you don't add these numbers, you multiply them. And multiplying rare probabilities together makes the final number drop exponentially, not gradually. This is the same math behind why winning the lottery twice sounds impossible, but isn't actually impossible. It's just astronomically unlikely. Geneticists studying outlier traits, like those at Decode Genetics in Iceland, have used massive population databases to estimate just how isolated certain trait combinations are. Their findings consistently show that as you add more rare traits, the pool of people who could theoretically have all of them shrinks toward populations smaller than entire countries, sometimes smaller than small towns. By this point in our build, we're no longer talking about a rare person. We're talking about a number that may not currently exist in any living human on Earth.
So let's do the math properly, live, right now. Rh-null blood, roughly 1 in 6 million. Tetrachromacy, roughly 1 in 10,000, and almost exclusively in women. CCR5 delta 32 double mutation, roughly 1 in 100. Extremely low resting heart rate combined with elite fast twitch genetics, roughly 1 in 10,000. Multiply these together, and the odds of finding a single person carrying all of them simultaneously come out to roughly 1 in 60 trillion. That's 60 trillion. To put that in perspective, there have been an estimated 117 billion humans who have ever lived in all of history. 60 trillion is over 500 times that number. Statistically speaking, this exact combination of traits has almost certainly never existed in a single human being. Not now, not in the past, and likely not for a very long time into the future, even as the global population grows toward 10 billion. This is the moment where the abstract becomes real. We just mathematically proved that the rarest possible human we built isn't just rare. By every reasonable statistical model, they shouldn't exist at all. And yet, every single trait we used is real, documented, and currently alive in someone, somewhere, scattered across the planet in tiny, disconnected fragments. So what does this actually tell us? It tells us that rare isn't really about one trait, it's about combinations. Every person watching this right now is in some way an impossible combination of traits themselves. Not as extreme as the one we built today, but mathematically no two humans, not even identical twins raised separately, end up statistically identical once you factor in environment, epigenetics, and microbiome variation. In a strange way, this whole exercise proves the opposite of what it set out to prove. We tried to build the rarest human possible, and ended up proving that, biologically speaking, every human who has ever lived already qualifies. If this kind of deep mathematical look at human biology fascinates you, this channel is exactly where you want to be. We break down the strangest, rarest, and most statistically wild aspects of human existence every single week. So do me a favor, hit that subscribe button right now so you don't miss the next one. And before you go, I want to know, if you could have just one of the traits we talked about today, golden blood, 4-color vision, HIV resistance, or an elite athlete's heart, which one would you pick and why? Drop it in the comments below. I read every single one, and I'll be replying to as many as I can. Thanks for watching. I'll see you in the next one.